Okay, I'll show you what I've done here with the stabilizer legs. Took them back into Branson. I had them put a knurl, a diamond knurl, really grippy now. And that runs the entire length of the shaft. And there it is on the inside. So, my hope is that that is going to resolve my slippage issues. The other adjustment I'm making is I'm taking these closed cell foam pieces that I've just cut out. I'm going to put it in between the floor and the clamp because it's a little wider and there's still room for bugs to get up in between there. So by putting this up in here and then having the clamp push up on it, that's going to create a really nice airtight seal. And then this thing will be completely impervious to all kinds of critters, snakes, skinny alligators. I'm using these little elastic hair bands and I'm putting them on the inside on the top of the tube so if it slips, it's going to push the band up and there'll be a gap and I can see that it's slipping on me. Good girl. That's how you do it. Stella, watch out. Whoa, shit. We lost the stabilizer leg. That's not good. That might have been a very, very expensive lesson. Oh, looks like we've got a failed test. So frustrating. I got in there as soon as Stella got in. Front right stabilizer leg collapsed a bit on me. So it's still not gripping even with that very expensive knurl. Ouch. I was so convinced that that was going to be the solution. I should have listened to the guys at Granger. They said, oh no, that's not going to work. Once I explained what I was trying to do. I said, what do these guys with 30 years experience in their trade know? They don't know anything. Okay, so I went back to Branson and had them drill a bunch of holes. Bought these stainless steel pins. You can see that it's resting up against the clamp and pushing against the closed cell foam to creating a seal on that opening. So that's the solution. I'll let you know how it goes. Expensive. I came across SBM Solar while doing research on custom solar panel manufacturers. They came highly recommended by another company in the space. And when I sent the email to Osbert, the founder, he and his marketing team got excited about the cyber drop and they said, we want to sponsor you and give you the panels as a sort of value in kind. So they actually made these panels custom ordered to my specifications at no cost. So they are the first official sponsor of the cyber drop, and we're going to put these panels through the paces in the months to come. Woohoo! Yeah! SBM Solar, custom manufactured in the United States of America. Look at that beautiful piece of work. Impressive. So it says to Osbert at SBM Solar, I said, what if we surrounded the roof vent with solar cells? Is that possible? Is it even worth it? He said, absolutely. And then made this roof vent solar cell crown. This is the centerpiece. 300 watts in one panel, lightweight, resilient, and voila! Oh, that's so cool. The dimensions of my roof didn't allow me to maximally use commercially available products like from SunPower. So if you're in a position like me and you want to maximize your surface area and you want to go custom, highly suggest giving SBM a look. They can spec something out that will work perfectly for you. So to create clearance underneath the solar panels for the junction box, I'm going to use two pieces of coroplast. One is a 1/4 inch, the other is 1/2 inch. gonna do a test with the VHB tape here, and then we'll come back in the morning and try to pull it apart and see how strong it is. I bet you it's gonna be plenty strong. I'm also rethinking at the front, at the leading edge of the panel that's going into the wind. I was thinking about putting a straight strip across to prevent any wind from getting under there, creating lift, but I don't think I'm going to be going that fast where that's going to be a real factor. If anything, I want the wind coming through and creating more cooling. I did some research. Apparently the ideal air gap under a panel is 10 centimeters. And this is only going to be, less than 2 centimeters. So that airflow is going to take away a lot of that heat in that hot summer sun. So maybe I want to keep that open. I don't know, my instinct tells me that's going to be okay, but we'll have to see how it goes. That looks good to me. I want the top lip of this one to cover the front lip of this smaller panel here so that the air goes over top. May as well get used to ChatGPT if this is the future.
I have a partially used roll of 3M VHB tape. The tape is 1/16 of an inch thick.
A couple little custom pieces I got to cut through here. This is more arts and crafts than anything. Some corner support on the edge of the panel too. I think that's important to have some corner support so it's not lifting in the wind, obviously. Actually, I've determined this was all a waste of time because the channels are now running perpendicular to the flow of water. So all this is going to do is cup a bunch of water right against the junction box. Not ideal. So I got to redo this. Away we go. Just got it loosely on top. That's the final layout. In order to have room for the cable glands right in here, I literally have not even a millimeter to spare. It's going to be right up against the caulking around the roof vent. It'll be good to have a source of energy when I'm off grid. So, SBM has given me the test reports for each panel, so I can take the statistics, take the data points I need to calculate wire gauge. Let's ask ChatGPT.
Is there any advantage to using a thicker gauge wire to increase or to reduce voltage drop?
It's frozen. I stumped the AI. Are you alive? Using a thicker gauge wire can indeed help reduce voltage drop and maximize current flow in a solar panel system.
I just told you my voltage is 62 volts. Why aren't you listening?
Go up in stages. Not quite a perfect circle, but I think thankfully it's going to be good enough. And then I'll put some caulk around there. It's going to be fine. Tell me it's going to be okay. Are we going to make it, Stella? I need to know. Let's go get the panel. You gotta stay out of my way though. Next step, cut these where I marked them. Don't cut both wires at the same time or you're short across the wires and you'll be effed. I'm just going to use this to protect the rest of the surface while I sand the outside of the holes. In my right hand, I'm holding a tool that I designed in SketchUp and printed on my 3D printer. It's basically a hexagon tube that fits snugly around the gasket nut while I fasten it on the roof side. Alright, that's the end of part 1 of the solar install. I'm going to have a part 2 video up soon. I'm also going to have a video of the battery build. Maybe that'll be part of the next video as well. But I'm getting close to the end here, and geez, halfway through summer, I better get moving if I'm going to depart on my world expedition by the fall. See you in the next video.